Hello, good morning to all of you. Next capacity finding formula for the data communication channel is Shannon's theorem. In reality, we can't have a noiseless channel. The channel is always noisy. When there is a noise present in the medium, the limitation of both bandwidth and the noise must be considered. Spike may cause a given level to be interpreted as a signal of greater level, a smaller level if it is in a negative phase. Noise become more problematic as the number of levels increases. In 1994, Shannon introduced the formula called Shannon capacity to determine the theoretical highest bit rate for the noisy channel, and this formula is capacity equal to bandwidth multiplied by log 2 1 plus SNR. Here C is nothing but the capacity, B is nothing but the bandwidth of the channel, SNR is nothing but the signal to noise ratio, and capacity is the capacity of the channel in bits per second. Noise ratio is calculated as SNR equal to average signal power multiplied by divided by. Consider the example. Consider an extremely noisy channel in which the value of the signal to noise ratio is almost 0. In other words, the noise is so strong that the signal is fed. For this channel, the capacity C is calculated as C equal to B of log 2 plus 1 plus SNR. B of log 2, SNR is here is the 0, 1 plus 0. B log 2 1 equal to B multiply 0 equal to 0. This means that the capacity of the channel is 0 regardless of the bandwidth. In other words, we can't receive any data through the signal. Next example, we can calculate the theoretical highest bit rate of this regular telephone line. A telephone line normally has a bandwidth of, the signal to noise ratio is usually 3162 to 3162. For this channel, the capacity is calculated as C equal to B log 2 1 plus SNR, 3000 log 2 1 plus 3 to 3162, that is 3163. 3 raised to log 2 by calculating the 3000 multiplied by 11.62, and the answer is 34,860 bpps. 32,860 kbps. If you want to send the data faster than this, we can either increase the bandwidth of the line or improve the signal to noise ratio. Next important topic in this chapter is performance of the network. The network performance is highly dependent on delay product. Networking is the performance of the network. Performance of the network depend upon the several factors just shown in the figure, that is bandwidth, throughput, latency, bandwidth, delay product, and jitter. In computer network, the term bandwidth, we see all the performance factor one by one. First factor is the bandwidth. In networking, we use the term bandwidth in a two context. It is the measure of the data that can be transmitted from one point to the another in given amount of time. To measure network performance, the one characteristic is the bandwidth. In networking, we use the term bandwidth in two. First is the bandwidth in hertz and in bits per second. In bandwidth, refers to the range of frequencies in the composite, the range of frequencies that the channel can pass. For example, the bandwidth of the subscriber telephone line is the 4 kilohertz. Next, Context is the bandwidth in bits per second. The bandwidth in bits per second refers to the speed of the bit transmission in a channel or link. For example, the bandwidth of the fast Ethernet network or the link is a maximum of 100 Mbps, means the network can send 100 Mbps. There is an explicit relationship between the in hertz and the bandwidth in per bits per second. As increase in bandwidth in hertz means an increase in bandwidth in bits per second. Next important character or the next important factor for the performance is the same. Throughput is controlled by available bandwidth. A link may have bandwidth of b bps, but we can only send t bps through this link, with t always less than b. Bandwidth is a potential measurement of the link, and throughput is an actual measurement of how fast we can send the data. For example, if you are considering the highway designed to transmit 1000 cars per minute from one point to the another. However, if there is a congestion on the road, this can be reduced to the 200 cars per minute. So, bandwidth is 1000 cars per minute, and through net 12,000 frames per minute, with each frame carrying an average of 10,000 bits. What is the throughput of this network? We can calculate the throughput as throughput equal to 12,000 multiplied by 10,000 divided by 60, that is 2 Mbps. The throughput is almost 1/5 of the bandwidth in this case. Then next is the latency. What do you mean by the latency? The latency or delay defines how long it takes for an entire message to completely arrive at the destination from the time of first bit it sent out of the source. The formula for latency is latency equal to propagation time plus transmission time plus queuing time plus processing delay. And how to calculate the distance between two divided by propagation. Thank you. Thank you.